think we're live. Hopefully, this is working. I don't know. Uh, let's see. Trying to do it from my computer was not working, but evidently looks like I'm able to do this from my phone. So, I don't know what's going on here. But we'll go this route. So what we're going to be doing is module 8, where we had left off. It is raceways, conduit. I believe that's where we were. And no, that is not where we were. Not module 8. Module 9 should be where we're at, I guess. Just looking through and finding conductors and cables. Yep. So, conductors and cables is where we're at. Module 9. Module 9. As an electrician, you will be required to select the proper wire and or cable for the job. You will be required to pull the wire or cable through conduit runs in order to terminate it. This module describes the different types of conductors and conductor insulation. It also explains how the conductors are related and classified by the NEC. Different methods used for pulling these conductors through conduit runs are also discussed. So that's the gist of it. That's what's going on here. So it's wire size. It's wires, conductors, cables. We're talking the same. It's how we get the electricity to the point where it can be used by a motor, machine, whatever it is. Wire size, wire sizes, and this is this is something that a smart guy would write down. Wire sizes are expressed in gauge numbers. The standard system of wire sizes in the United States is the American Wire Gauge System, the AWG or AWG. So the American Wire Gauge is used not only for wire, but it's also used for other things. You can probably think of different things that you would have a certain gauge in, whether it be piercings. Those are the same sizes. Also, you get into other things that have that gauge system. But the American Wire Gauge is how we go about it. When did the house, it was a lot of 14 and 12 gauge wire. There was a little bit of other stuff. You get some 10, you get some 6, you get into the service entrance cable, which get into the then you get into the aughts, 4-aught, 3-aught, 2-aught, and you get into that. The American Wire Gauge, you'll need to know, the larger the number, the smaller the cross-sectional area of the wire. And you guys should know this already from wiring up the house. When you talk about 14, it's smaller than 12, and 12 is smaller than 10. The smaller the number, the larger diameter that it is. That's another note that you need to have. The larger the number, the smaller the cross-sectional area of the wire. You need to make sure that that's one of those things that you do know. Also, 4/0 wire has a greater cross-sectional area than 3/0. So when you get into the aughts, that you start counting up. So 2/0 is smaller than 3/0, which is smaller than 4/0. You're adding a zero each time, and that will make it larger at that point. So you need to make sure that you know that 4/0 is bigger than 3/0. Good note to have. Stranding. According to the NEC, Chapter 9, Table 8, and this is, we talked about the NEC a little bit. This is one of those things that you'll need to, it'll refer back to Chapter 9, Table 8. That's a lot of wire information. But according to Chapter 9, Table 8, wire sizes number 18 to number 2 have 7 strands. Wires number 1 through number 4/0 have 19 strands, and wire sizes between 250 kc mil and 500 kc mil have 37 strands. The purpose of stranding is to increase the flexibility of the wire. So when we start talking about larger wires, you get more strands, and it increases the flexibility. When you get into like the 500 kc mil, or as some of the old timers will call it, 500 MCM, that is it's basically a number 12 or number 10 wire that's inside that jacket, and you figure it says 37 strands. They're just bunched in there together, but they're quite large. But that's a very large wire, and it handles quite a bit of power. But if that was solid, or if it had less strands, it would be much harder to deal with. So you need to know the purpose of stranding is to increase the flexibility of the wire. That is to just be able to say, this is why we use stranded over solid. There are certain times where solid is the better way to go, but when you start doing commercial, industrial, you're going to generally deal with having a stranded wire. So you need to make sure you know that. There are different types of conductor insulation. That's the different types of wrap on the wires. So you need to know when you're color coding, 2 conductor cable is 1 white or gray wire and 1 black wire, and a grounding wire usually bare. So that would be similar to your Romex jacket being together. And then also in a flexible jacket, like an SJ or an SO cord, you'll have, but that will be not a bare ground, but a wrapped ground, green wire. And a 5 cable conductor, again, this is something that you need to know. In a 5 cable conductor, it's got a white or gray, a black, a red, a blue, and then the 5th wire would be yellow, and a 5 conductor cable. So you have a white, black, red, blue, and yellow. And that's your 5 within that one cable. That's one of those things you need to know. And also make sure that you have this written down somewhere or whatever, along with the other 2. The grounding conductor may be bare, green, or green with a yellow stripe. The power cable codes are shown on figure 5. Now, if you've been able to get on Schoology and you've been able to see what's going on, you can go through the module slides and see everything there. If you are having trouble, let me know, so that way we can work it out, figure out what's going on, and get it going. Get you able to get on there. I want to be able to get everybody on there. The district would like everybody to be able to be on and using Schoology. So I know that a few of you have, but not everybody has been able to get on there. So if you're having trouble, you can text me, email me. I'm learning how to use that, so that way I can help you be able to learn to use it. Moving on here, NEC Article 310 and the ampacities of conductors are given in NEC tables 310, 15B, 16 through 310, 15B, 21. So you need to know how to find ampacities within the NEC. So the ampacities of the conductors are given in NEC tables 310, 15B, 16 through 21. So it's table 310, 15B, 16 through 310, 15B, 21. That's where you find your ampacities. And then using the ampacity tables, an important step in circuit design is the selection of what type of conductor to be used. And there's several different types of conductors that can be used, and it all depends on what conditions they're going to be in within the conduit or within the raceway that they're in. What kind of things are they going to be exposed to? So if you are going to be exposed to whatever, you have to know, if it's a toxic environment, you have to know what coating you want in there. That's the job of the engineer generally. But as we're in the field, as we're doing things, we have to also take in mind what is it that we're trying to accomplish here. We don't want to set it up to fail in a short time. We want it to last So we have to know what coating goes where and choose the right coatings. So, but if you're strictly looking for ampacities, that's NEC table 310.15, 310.15, B16 through 310.15, B21. For the varying conditions of use in the raceway open air at normal or higher than normal ambient temperatures. So you have to, like I said, there's all kinds of things that come into play, but you have to be aware of what's going on. Need to take note of also the decision of which fixture wire to use depends primarily on the operating temperature. And again, that goes back to that coating. It goes back to that knowing what wire goes where. It's going to really depend on what your temperature, your operating temperature, what your ambient temperature is going to be, so that you can set it up right and be able to not have an issue that way. So you need to know the decision of what fixture wire to use depends primarily on operating temperature. That's the biggest thing. It looks like I got 2 people watching. Hopefully that's correct. If you do need to say anything, want to say anything, the chat should be open. Hopefully it is. If it's not, you can text me after this or whatever and let me know what's going on, and we'll get it corrected. Again, I'm learning how to do this on the fly. So cable markings. Cable markings need to make sure. Now, cables are 2 or more insulated wires that may contain a grounding wire covered in an outer jacket or sheath. So these are your, these are like, you can make an extension cord out of SJ, SO cord. That's a bundle of wires that has a jacket. And it says cable is usually classified as a type of covering. It has either non-metallic, plastic, or metallic, also called armored cable. So your Romex is a cable. Your extension cord is a cable, but also your flexible jackets, your armored cable, even though it's metal, if it's flexible and can be pulled through, that is a cable as well. So cable markings, you need to know this, need to have this down. Cable markings show the wire size, number of conductors, cable type, and voltage rating. So back to that example of Romex, it has your wire size, which now is, if you the 3 main that you're going to deal with, white, yellow, and orange, you know just by the outer jacket what the cable size or what the wire size is on the inside. So if I say, hey, you've got a 12-3, you know, oh, okay, that's the yellow wire there. Or I need a 10-2, okay, that's the orange. I know that I'm going after that. But it also has the cable type and so it'll say non-metallic, and then the voltage rating, which is under 600 volt, or as the lineman would say, low voltage, anything under 600. So you need to know those, the wire size, the cable type, and the voltage rating are on the jacket of your cable. So going on, non-metallic sheath cable, NM or NMC, widely used for branch circuits. That NM would be your Romex non-metallic. So non-metallic sheath cable, it'll be marked on the outside. The sheath covering type NMC cable has the additional characteristics of being fungus and corrosion resistant. The sheath covering type NMC cable has the additional characteristics of being fungus and corrosion resistant. You need to know that. NMC is fungus and corrosion resistant. That's something vital for what you are going to be using. I'm going to try to make this work here about 10 more minutes, like a normal lecture time. And then I want to go ahead and try to do another one of these and on Friday, hopefully, and get more up online with everybody. But if not, these are always going to be able to be there to go back and refer to for anybody who misses it. So it'll work out. I know some guys are working and they'll have to go back in later. Article 334 lists the allowed and prohibited types of NM cable and NMC cable. Both are allowed to be installed in either exposed or concealed work. Both are allowed to be installed in either exposed or concealed work. So exposed, like the garage that doesn't have any, the garage doesn't have anything in the, any covering on the wall. It's all open studs. You can use Romex, but you can also use Romex when you put drywall on the wall and cover it up and not have it out so it can have that temperature difference. Also, it doesn't matter whether it runs through an insulated wall or whether it runs through a non-insulated wall. It's still there. Type UF cable. You need to know type UF cable is suitable for direct burial. So that's the, it looks like Romex gray jacket, and it's suitable for direct burial. It's what you'll run if you just have a clubhouse that somebody puts out in the yard. They put their clubhouse out there for the kids, and they go and they want power in there so they can turn a light on, or they can have a TV out there or whatever. You know, might be if you're not running a lot of power out to Sheila's she shed. You know, you might run a UF out and have a plug and a light. That would be enough for that circuit, and you wouldn't have to bury a lot. And that's something you can just knife in. You don't have to dig a big trench and those kind of things. So it works out really well to be able to use type UF cable, and it's suitable for direct burial. You need to make sure that you have that written down. Type NMS cable, and type NMS cable is a form of non-metallic sheathed cable. Non-metallic sheathed cable is NMS. Non-metallic sheathed cable. NMS. Contains factory assembly of power, communications, and signaling conductors enclosed within a moisture-resistant, flame-retardant sheath. So NMS has its factory-assembled communication and signaling conductors enclosed within a moisture-resistant and flame-retardant sheath. That's the what's contained in there. That's what you need to know. And then there's type MV, medium voltage cable. There's type MC. MC cable is that metal clad, that flexible metal conduit. We've got a little bit of it there in the shop. If we can ever get back, we'll look at it. I think most everybody knows what it is. Some of the typical uses for the three types of MC cable are for services, feeders, and branch circuits. So you need to know that some of the typical uses for the three types of MC cable are for services, feeders, and branch circuits. Services, feeders, and branch circuits. So, with MC cable, it is a wide variety of applications. Small instrumentation cable up to medium voltage feeders. Be coated in a thermoset or thermoplastic insulation. MC cable can also be composed of electrical conductors and fiber optic conductors. But you need to know that the three types of typical uses, or the typical uses for the three types of MC cable are services, feeders, and branch circuits. And just a few more notes and we'll be done for today. You need to know that type FCC is flat conductor cable. FCC is flat conductor cable and comprises an entire branch wiring system similar to many respects of the type FC, the flat conductor assemblies. So FCC cable consists of 3 to 5 flat conductors placed edge to edge. So it's a special cable, FCC, flat cable, telephone, and other communications usually who are using that. Type TC cable, power and control tray. Type TC cable consists of 2 or more insulated conductors twisted together with or without associated bare or fully insulated grounding conductors, covered with a non-metallic jacket. The cables are rated at 600 volts. Cable is listed at conductor size 18 AUG to 2000 kc mil copper, or 12 AUG to 2000 kc mil aluminum or copper clad aluminum. So type TC cable consists of two or more insulated conductors twisted together with or without associated bare or fully insulated grounding conductors. So they're twisted together. Type TC cable is also good for use in sunlight when indicated by cable markings. It's kind of a you have to know where to put it, when to put it. SE and USE cable, service entrance and underground service entrance is what those are. SE cable and USE cable, the underground service entrance. When you need to know when used as service entrance cable, type SE must be installed as specified in Article 230 of the NEC. When used as service entrance cable, type SE must be installed as specified in NEC Article 230. So you have to make sure that not only are you installing the correct wire, but you're installing it in the correct manner. And lastly, for today, we'll stop here. The last thing you need to know is a shield drain. A shield drain. A shield drain is a bare copper wire used in continuous contact with a specified grounding terminal. A shield drain allows connection of all the instruments within a loop to a common grounding point. Typically, the shielding of instrumentation circuits is grounding at one end and the conductor only. So you need to know a shield drain allows connection of all the instruments within a loop to a common grounding point. So this would be an example of that would be like your bar, your grounding bar within your main panel. Shield, that's a shield drain, grounding point there that allows for you to be able to go to one point and not have to go any further to be able to get to your grounding. So we'll pick up after that. We'll start talking about the installation of conductors in conduit systems, how you go about doing that. We'll talk about that on Friday. Make sure that you go back, take the notes that are there, do what we need to do. Like I said, I'm working on getting everything worked out and be able to do what we need to do. But until then, you can get a hold of me and do what we need. Thanks.